Hello, everyone, and welcome to Characteristics of Linear Relations, Lesson 4. So in Lesson 3, we looked at discussing what the slope of a line means and how we measure it. And now we are going to look at coming up with a mathematical formula to calculate it. So just as a quick review, slope is the measure of the steepness of a line. So it's the steepness. Slope is the ratio of the vertical change, which we call the rise, over the horizontal change, which we call the run. A line segment that rises from left to right has a positive slope, and a line segment which falls from left to right or goes down to the right has a negative slope. A horizontal line has a slope of 0, and a vertical line has an undefined slope. And slopes of all line segments on a line are equal. What they mean by that is if you had a long straight line, you could measure the slope between these 2 points, you could measure the slope between these 2 points, or you could measure the slope between those 2 points, and it should be equal if it's a straight line. The steepness is going to be the same anywhere, right? The slope will be the same between any 2 points. All right, so let's look at developing the slope formula. So it says here, calculate the slope of a line segment AB using rise over run. So we know we like to choose 2 points where the line goes through whole integer points. So it looks like here I can say, okay, my rise is going to be 1, 2, positive 2, and my run will be 1, 2, 3, 4. So 2 over 4, and then we want to reduce that as much as possible. So 2 over 4 becomes 1/2. Awesome, that was pretty straightforward. List the coordinates of the endpoints of line segment AB. So the endpoints are right here and right there. So it looks like A is at positive 1x and positive 8y. So 1, 8. And B is at 7x, 11y. 7, 11. How can the rise of the line segment AB be determined using YB and YA? Well, YB is 11. That's the Y coordinate of point B. And the Y coordinate of point A is 8. And I know that my rise is going to be, well, our rise over run is 1/2. So can we figure out how to calculate the rise? Well, we can go YB minus YA. And what we'll get is 11 minus 8. And that gives us a rise of 3. So a rise of 3. And we're going to do the same thing for the run. So x coordinate of B is 7, and the x coordinate of A is 1. So if we go xb minus xa, we're going to get 7 minus 1, which gives us 6. So we have a run of 6. Use your results from C and D to write a formula which describes how the slope of a line AB can be calculated using its endpoints. So before we do that, I just want to point out that if we use the rise that we calculated and the run that we calculated up here, we're going to get rise over run, which is 3 over 6. And if we reduce that, we will get 1/2. So the slope ends up being the same. So what we can do here is create our slope formula. So we know slope is rise over run. And we were able to calculate the rise with yb minus ya. And the run is xb minus xa. So we can rewrite that if we want. Slope is equal to, and instead of using b and a, I like to use it as 0.1, 0.2. So then you get slope is y2 minus y1 over x2 minus x1. And that's your slope formula right there. Calculate the slope of the line segment AB using the formula in E. Well, we kind of already did that, but I can say slope is equal to y2 minus y1 over x2 minus x1. And then I can fill out my numbers. It's a good habit to get into to write your formula before you start filling numbers. And I know that every student always tells me, well, it's more work and I have to write more, but it's going to reduce the amount of errors you make. A pinky promise. Okay, so we can fill that out. So the y value of our second point, or our y2, is going to be 11 minus the y value of our first point is 8. 11 minus 8 over the x value of our second point, which was 7, minus the x value of our first point, which was 1. 11 minus 8 is 3. 7 minus 1 is 6. 3 over 6 is 1/2. There you go. So it's a matter of just plugging in the values here. A couple things you want to be careful of is don't mix these up, right? If you're using the second point to begin with, always use the x2, y2 to begin with, and then subtract the 2 points from the beginning. If you get those mixed up and you have this x before, so you have x1 minus x2, you're going to get the wrong slope. It needs to be y2 minus y1, x2 minus x1. It needs to be consistency, 2 minus 1. Okay, so I'm going to skip that and we will do a quick example, and then I think this video is going to be over. So the slope formula again is right here. I want to point out one thing, that in math we use the letter m to represent slope. M is slope. So when we rewrite our slope formula, you can say m is equal to y2 minus y1 divided by x2 minus x1. And then you can go from there to find slope. So I know if you have a graph, it's easy to count the rise and the run, but if you're given a question like this one right here, you can use the slope formula instead of having to graph everything. So I'm going to cross that out because I'm going to use this one, which makes more sense. So the question says, find the slope of a line which passes through the points G and H, where G is -3, 8, and H is 7, -2. So the first thing you're going to want to do is label these. This is whether this is point 1 and this is point 2, or vice versa, you just need to keep consistency. It'll always come out to be the same answer. So I'm going to say this will be point 1, this will be point 2. If you labeled them opposite, that's okay. The math will work out. So this becomes then my x1 and y1, and then my x2 and y2. So my formula, m, for slope is y2 minus y1 over x2 minus x1. And remember, the y's go on top because slope is rise over run. That's why the y values go on top, because the y represents the change in the vertical direction. So y2 is -2 minus y1, which is 8. x2, which is 7, minus x1, which is -3. And we can calculate. So -2 minus 8 gets me -10, right? I start at -2, I'm going 8 more negatively. 7 minus -3. Whenever you subtract a negative, you can chop and make it plus. So 7 plus 3 is 10. So our slope is -10 over 10, which we can reduce to -1 over 1, or just -1. So our slope is -1. Awesome. That's how you use the slope formula. I think we're going to stop there for the day. I know it was a pretty short video. We're not going to do the collinear points, but we will get focused on just making sure we are comfortable with the slope formula and practicing it. And then, yeah, that's it. That's awesome. Don't forget to like and subscribe. Thank you for watching.